Hello and welcome to this Cloud Native Trainer course on Azure Terraform for Beginners with me, Mike. Today we will cover what Terraform is and how to use it with Azure to deploy Azure resources. Specifically, we'll be using Azure Cloud Shell to write some Terraform and run it to create a simple static website hosted on Azure storage. So what is Terraform? Terraform is a tool from HashiCorp, which is essentially an abstraction around a cloud provider's API. It enables us to write code declaring what we want, and it handles the complexity of deploying it for us. I find it useful to think of it like a blueprint of a house that you give to a builder, Terraform in our case, who will in turn come back with a completed house for us to use without us having to lay any bricks ourselves. Okay, let's get started. So today what we're going to do is deploy an Azure static website using Azure Storage to show an index.html file in a browser using Terraform. And we're going to do it using the Azure Cloud Shell. And the reason why I want to use Azure Cloud Shell is it already has Terraform built in. You're already connected to Azure, and it has a simple text editor that we can use to show how all this works. Now, in the real world, you will most likely use something like Visual Studio Code, have Terraform installed on your laptop, and work with it that way. But to show the basics and how this works, I'm going to show you Azure Cloud Shell, and we'll go through the steps bit by bit. So first things first, we need an Azure Cloud Shell. So if we head over to the Azure portal, so portal.azure.com, once you're logged in and you have obviously an account or a subscription, on that subscription you're going to need contributor or owner role in order to run this, but that's pretty much default if you sign up for any of the trials. Once you have all of that set up, you can come up here and there's a terminal icon, so we click on that. And you can see it's now requesting a Cloud Shell for me. Now for you, when you first start this, in all likelihood, you will be asked to create an Azure storage account to go with Azure Cloud Shell. And that's just so it's got somewhere to store its files. There's also an option if you decline that to have transient storage, where basically there is a storage account, but I think it gets purged when you close the session, so it's not persistent. Also, the other default that you'll find is this will say this will start in a bash terminal rather than PowerShell, and you'll have to go over here and switch to PowerShell. Now, because I've been using this myself, it defaults to the PowerShell session, which I've been using. So let's give ourselves a little bit more screen real estate. So if I do maximize the screen there. Also, if you want to skip going into the main portal, there is a shortcut. You can go to shell.azure.com. That basically gives us the same thing, but full screen by default. And there's no option to move this bar down like there is on the other one. Okay, so while we wait for it to give us the session, so it's building my Azure drive, the next thing that I'm going to want to do is turn on the editor. So this is so I can see the files that I'm working with. So I want to click on this. It's going to ask me to switch to the classic Cloud Shell. Just confirm that. We'll then reload the session again. Okay. And now if I click on the parentheses or the open editor, I now get a VS Code lightweight style shell editor. You can see we have this cloud drive, which is basically where all my files go, and then there's a whole host of the Microsoft stuff. So the first thing I'm going to do is I'm going to change it into the cloud drive. And for the purpose of this demo, I'm going to make a new directory. I'm going to just call it Terraform. And we can't see that here at the moment, so what you have to do each time is come to this refresh icon, and now you'll be able to see it. So that we've got Terraform, and I can start creating files. One drawback of using this approach is that this file editor doesn't have an option to create files, but we can do that in the terminal. And since we're in PowerShell, we can just do new item and then the name of the file. So given we're working in Terraform, I can just do, well, actually, it would make sense to first change into the Terraform directory. Now I'm going to do new item. We're just going to start with the main.tf file. Okay, hit refresh. Right out here. Now we've got main.tf. And there's also going to be some other files that we're going to need. I'm going to need a providers file. Let's have variables file. Let's have an output file. Not outputs. Refresh those. What's that give us? And I'm also going to want an index.html, which will ultimately be what we end up deploying. Okay, refresh. Now we've got a whole load of empty files that we're going to need to populate. So, first things first, let's set up the providers. Now, to make this a little bit quicker, given there's an awful lot of copy and pasting that we want to do, I have created a Git repository called Azure Terraform under my Git area, Mike W. Kelly. And within that, we can see all the files that we're going to work with. So for the providers, there's two that we're going to require. There's the Azure RM provider, and there's also the random provider. I've included links to each of them. So within the code, if we copy, let's go to the official documentation. So you can see here is the Azure provider. This is the thing that makes the magic happen. So this is essentially a set of APIs which Microsoft manage, and then Terraform provide a wrapper around that. You can see an example usage where we'll specify the required version of Azure RM and then whichever features that we're going to use. And then below here is just creating some resources using that. So we've got a quite simple setup here where we're just going to use the Azure RM version greater than 3. And we will also want the HashiCorp's random provider greater than 3, and we're not using any special features. This is also where we're going to set our Terraform version, and we're just going to have it greater than 1. That's quite straightforward. So I can copy the raw file, go back to my dashboard, I can copy and paste this in here with Control V, and then I can do Control S to save. Next, the main file for Terraform is main.tf, and again within my GitHub repository I've got a file with all the information that we need. So I'm going to copy that over here, I'm going to paste it in, I'm going to save it with Control S. And let's just talk you through this. And again, I've provided the documentation link so you can see in more detail what each of these are doing. But for the moment, we have data, which is basically a data import, which is getting the current Azure client. We've got a random pet resource, which is almost a nice to have. This is not critical. You wouldn't typically use this in production code, but for this example, all we're doing is we want a unique resource group name, and we're going to use this random pet function essentially to generate it for us. You can see that it's consuming it here. Our resource group resource is going to use the random pet resource, and then there's some other things in here, including the storage count. So the storage count is ultimately where we're going to be hosting our HTML web page. And each storage account needs a globally unique name. And so we're going to create a random string. And for this, it's just going to be 8 characters long. We're going to use lowercase, and we're not going to use any special features at all. And then there's the storage account itself, For that storage account, we're just going to have a standard storage account. We're going to have locally redundant storage, so no geo-replication, that kind of stuff. And because it's a static website, we can pass in what the index document is going to be. And in this instance, it's going to be index.html. And then within a storage account in Azure, there's a blob. So a blob's basically the container, which then contains the files. And we're simply specifying here what type of content is inside that and what the file is. So we've got the name of the file, we've got the content type, which is text HTML, and then the source of it, which is the file within our repository. Okay, so moving on, the next thing we need to do is set some variables. So again, if we go back, let's go copy the variables over. Our variables file, let's copy these in. Variables can be changed. So in this instance, for example, I've got East US here, but actually for me, I live in the UK, so I want the resource group location to be UK South, so I can edit that here. And we're also using another variable for the resource group prefix. And in this instance, this is just RG following the Azure naming standards. And it's going to be combined with the random ID, so that pet name that we've got in the other module, to create a unique resource group name for us. Okay, so that's almost there. We've just got our outputs to go in terms of the Terraform code. So we go back to outputs. These are things that once our Terraform has run, it will give us this information so that we can use it. And for us, like the main information that we need is what's the primary web host. So what is the actual address for the website so that we can go and view our index.html file as a website. So again, let's copy that file. Let's go into our outputs. Let's paste it and make sure it's saved with Control S. And now that all that's left is for us to have some content to display so that we know that this has all worked. So again, I've pre-made one here. So there's an index.html. It's a very simple index.html file, which has got some basic elements in it. So a body, there's a div. I'm going to load an image. There's a couple of headers and then a paragraph. Nothing special. You could have a line of text as well. It would do the same job. So let's copy this raw file, paste this in. Okay, so one complication here is I have an image file and I need to upload it. So let's just show how that would work. So within our Terraform folder, I'm going to need an imgs folder. So let's make the directory. And now let's refresh that so I can see the folder. There it is. Then I want to upload a file. Okay, so I'm just going to go into my local repository for this, grab the file, click open, and then it has uploaded it into my home directory. So if I go back to the home, now see course cover.png. I'm going to need to move that into my images folder. We need to use move item. A good example here. So let's go and change that. Path will be course cover.png, because it's in the current folder. And then I'm going to want this to go to home, mic, cloud drive, Terraform, images. And then if we refresh, see that the files move there. Okay, that's all good. Okay, now that we've got all the files, we're going to want to do some actual Terraform. So the Terraform lifecycle is quite simple. We need to initialize our Terraform, and that'll go and download the providers from the internet, set up all the local structure, and basically get everything ready for us to work with. So let's do that first. The command is very simple. It's Terraform init, and we also want to upgrade at the same time to make sure that we're on the latest versions of any packages that it's using. Of course, you want to make sure that you're in the right directory, and I clearly wasn't there. So, remove that item. Okay, so because we initialized it in an empty directory, it didn't download anything, so I could just use the rm command with recursive and force flags to remove the folder. So that sorts that out if you make the same mistake that I've just done. So let's get into the right directory, go to Cloud Drive, Terraform, list this out. Yeah, all the files are there. Let's just clear the terminal so we can see what's going on. And then let's do a Terraform init upgrade. There we go, that's much better. It was initializing the backend, initializing the provider plugins. It's now finding, installing them, and getting everything ready to work. And that is now completed. So what did that do? Let's refresh. We can see that we have a .terraform folder now, and inside of that there's providers, there's registry, and we can see two entries, Azure RM and random, and there's a version number, and then ultimately there will be an executable. Same for random. But we can see these are all the files that it's just downloaded, and nothing else at this point. Okay. So what else can we do? So now that we've got our Terraform, before we run anything, we probably want to make sure that everything's formatted. And what I mean by that is that there's a standard way of formatting Terraform code. So you'll see here, for example, that all the equal signs line up. And there's a certain level of indentation. So just to show you how this might work, let's say I get rid of these in terms of the nice lining up. So these are all just the way I'd typed it in the first place. So I'm going to control and save. So very basic example. But now if I use the Terraform format command, FMT, and hit enter, it will now go through all the files in the directory and format them in the Terraform standard. So if I just go to another file, back, you can now see that the alignment's been restored. So very basic, but it's a good way of making sure that all your code is consistent. Now the next command we're going to use is Terraform validate. So this will go through all Terraform code and check that it's valid Terraform, so we get errors before we run the next stage. Okay, success. Our configuration is valid. So it's checked all of our Terraform, and as far as it can see, everything's good. So that's great. So what can we do next? Well, next we want to do a Terraform plan. Now, the Terraform plan is where we run the Terraform command, Terraform plan. We can specify an output file. So we can say, okay, well, let's plan what this Terraform is going to deploy. Let's then make a plan file, which we can then use to do a Terraform apply in the next stage. And there's two options of doing this. You can do just a Terraform plan, which will run the plan and say, right, okay, well, here's everything that I'm going to deploy, and then you can then do the Terraform apply, and then ultimately essentially does a Terraform plan and an apply in one go. But The second option is where we specify it to create a Terraform plan file. And what this guarantees is that what we see when we run this particular instance of Terraform plan is what we can then apply at a later date. Otherwise, Terraform doesn't give any guarantees. So to show how this works, let's just do a normal Terraform plan. I'm not going to specify the actual output file on this instance. It'll take a couple of minutes to run, so bear with me. I'll speed this up in post. Okay, so if we just scroll up a bit, see, these are all the resources that Terraform is going to apply for us, or is going to deploy. So it's going to create a resource group, it's going to create the storage account. There's a whole host of settings that it will know once it's run the apply. It's going to create the storage for us. It's going to create a random pet name. It's going to set the random storage account name. So all in all, we've got 5 things that it's going to add, 0 things it's going to change, and 0 that it's going to destroy. And it's also going to output for us the primary web host, the resource group name, and the storage account name. And then you'll see what I was trying to get at before was on the note at the bottom. It says you didn't use the out option to save this plan, so Terraform can't guarantee to take exactly these actions if you run Terraform apply now. So just something to bear in mind. So let's clear the screen. And if we do Terraform plan out, hit enter. It'll again take a little while to go through it. Okay. So now you can see that the main difference is down here. So there's saved the plan to main.tf plan, and then to perform exactly these actions, run the following command to apply Terraform apply main.tf plan, which is what we're going to do next. And just to show you what it's generated, if I just put this down and refresh the screen, you can now see that we've got a main.tf plan, which isn't human readable. There is actually an option of making it readable. You can output it to a JSON format, but that's a more advanced topic. But for now, just take my word for it that this is the Terraform plan, and we can use it in the next step to apply the Terraform. And what it'll do within those actions, it's got the 5 resources that it's going to deploy. So the storage blob, the storage account, the resource group, and the other 2 bits. Okay, so let's just copy and paste this. And in Cloud Shell, if you are doing any copy and pasting to the shell itself, I recommend doing Control Shift and V to make sure that it applies to text. Otherwise, you can get some funny characters either side of it, which is fine. You can just delete those manually. But once you've done that a couple of times, you're going to get pretty annoyed with it. So Control Shift V gets around that. So for Terraform Apply is actually going to deploy our code for us. This is actually connecting to Azure using the Azure provider, and then it is running this code using the Azure APIs to deploy these Azure resources, which we will then be able to see inside of the Azure portal. So you can see the random strings have been generated for us. We've got the resource group Humble Rhino, and then some complete gobbledygook for the storage account name. Okay, all done after just over a minute. And what we can see here is as our outputs. The primary web host is the most important one for us. This is actually the URL address of where our index file will have been saved to. So we can very quickly go and see this. If I copy and paste this into the browser, you can now see our cloud native trainer, Azure Terraform for beginners. Isn't quite working as expected. Just have a quick inspect of that logo. Why isn't it could not find the images. So images, I suspect because I haven't actually included that in our Terraform, which is an interesting thing to see if I can fix. Okay. But that will lead us into the next bit, which is let's make a change. So, okay, let's go back to our shell. Let's just clear the screen. Okay, so what we're going to do is create another resource. So we're going to need another Azure storage blob. Let's just duplicate that one. Let's just call this image. We are going to want to have the actual name of the image. Of course, cover PNG. I'm going to want path, so images, and then course cover.png. That's going to be the same for the source, so I need to know which file to get it from our directory, and then all the other items stay the same. So we've saved that. What we would do next is do a Terraform validate. Make sure the change that I've made is actually valid. Okay, that's good. Now we want to do a Terraform plan, and let's output it to the main.tf plan again. So we can see now that we are only going to add the resource that we've added. So in this instance, we've got our image, and this is what it's going to deploy. But otherwise, it's not going to change anything. It's not going to destroy anything. Our change is good. So let's copy this to Control-Shift-V, and let's apply that. And it should just create a new blob image that we can reference from our index.html file. Okay, complete already. Right, so fingers crossed, if we now go over to our deployed website, we have the image and everything worked. Now let's kind of have a look at, just a quick look around at what we actually deployed. I can go in here and we will have our Humble Rhino resource group. And you can see that there's a single storage account in there. Go to storage browser, have a look at blob containers. We've got web, and then within web there is a folder with the course cover in there. And if we go back up one, we can see the index.html. So exactly what you'd expect for our deployed storage account. Okay, so what should we look at next? So it's probably a good thing to talk about how Terraform knew that we only need to add one thing rather than redeploy absolutely everything that was defined in our code. So if I just minimize this, I can talk you through the Terraform state. So if I hit refresh here, we now have a terraform.tf state file, and a state file is used by Terraform to track what resources it's deployed. So any time that you run the plan, it's comparing your code against the Terraform state to see if there's any change that it needs to make. And if there isn't any, then it'll tell you that the plan won't do anything. And if you're going to remove some stuff, it'll tell you what's being removed. And if you're adding stuff, it'll tell you what's being added. You can see that the Terraform state file is essentially just a JSON file which shows everything that's been deployed with its name, its ID, what the actual resource is, what provider is being used. And this is essentially a code representation of what's been deployed to Azure with your Terraform code. And it's the biggest difference that you'll find between using the Azure native tooling, so ARM templates or Bicep. Those don't need state files, but Terraform does. Now, if you were to do this in production, you would not have a Terraform state file being managed in a cloud drive or indeed on your local laptop. You typically would look at an alternative solution. So the Azure native way of doing it is using Azure Storage, where you would run a pipeline of some sort, of CI/CD pipeline, which would run your code against the state file in the Azure Storage. So every time that pipeline run, it would check it. Or you can use something like Terraform Cloud, which will manage your state for you again remotely, and you need to change your code slightly to reference that remote state. So it's the same for Azure Storage and Terraform Cloud. But we won't be covering that today. So for our simple example, you just need to be aware that there's a Terraform state file which is sat on your computer somewhere, and this is what Terraform is comparing itself against whenever it runs a plan. Final thing to do after we've deployed a load of Azure resources, assuming we don't need them anymore, which I don't, is to destroy them using Terraform destroy. So let's do that. It's very similar to Terraform plan. In fact, we use pretty much the same command. It's Terraform plan with the destroy flag, and we're still going to output to a TF plan. In this case, I've named it main.destroy.tf plan. So let's run that. Okay, so we know that we deployed 6 things because the first run was 5, the last run was 1, so 6 together. And you can see that Terraform has identified that we now have 6 resources to destroy. So that's working exactly as we expect. And as we've saved the plan, we can simply run a Terraform apply to run the destroy plan. So let's do that now. Control-Shift-V. And hit enter. This will take a couple of minutes to run. Okay, all done. 6 things destroyed. So let's just double check. If we refresh, go to our Terraform state, there's no resources in it. It's fully empty. So that's to be expected. Let's go over to the Azure portal, or the main part of the Azure portal. So we've been looking at the storage browser and this resource group. We'll go to it and try and refresh it. So there's nothing there anymore. And actually, if I go to my resource groups and let's refresh, so you can see Humble Rhino's there. It's now gone. That concludes Azure Terraform for beginners. If you like what you've seen, consider liking and subscribing. Till next time, I've been Mike for Cloud Native Trainer.